Okay, hello students. Here I am trying to solve practice problem because I've been always continuously in a process. I did one, then I did three, four together, then there is five, six, seven. And now right now I'm trying to do unit four and lesson number 8. So this is a practice problem. Problem number one. Look at the table. See if you can figure out. Pause the video for a while and see if you can do it yourself. Okay, so what does it say is you see there are number of dots is the output, input is the steps, number of steps. So write an equation to represent uh, between the steps and the number of dots. So we need to know what's can we figure out for 4, 5, 6, and what if it is n, and what how do we write the expression for number of dots? So you can clearly see it goes by so 1, 5, and there is a growth factor. You can see there's a growth factor which is 5 divided by 1 and 5. So every time you multiply 5. That means if I want to write the function f of exponential function is a times b raised to x. Now here I'm using, because they gave us n in the problem, so I'm going to, instead of x, I'm going to write n. A is the beginning, that's the A. Let me write again, B times N. So this is N. So the answer is, now the first one is given as A. When in the first step, there's a single dot. So 1 times, and then the growth factor is 5. So this is B. So 5 raised to N, and you're done. So that's the answer, which is 5 raised to N. Next question is asked, or if you want to really see what that means is in the beginning there was one dot and then after that there were one, like something like this, 5 dots, and the next one will be 25. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, and so on. That's all that means. But we're not supposed to show this. You can just very well say, okay, there are 25, and then comes 625. Question is, if you go on multiplying 5, so how many fives do we multiply? So question is, how many of this when you multiply 5 to get 9,765,000, that's what they say, right? So each student will try to do in a different way. So let me write here. Basically, you want to know 5 raised to n is when do you get uh, 9,765,000. 625 97625 97625 ah I forgot 979765. This is why 9765 and then again 625. So one way is just you can go on checking, multiply 5 times 5 times 5, and again see what is the answer, then multiply 5, what is the answer. So this is one of the strategy you can use by continuously multiplying 5. Another student will say, okay, no, Rebello, I will show 5 times 1, we use the calculator, or 5 times 2, 5 times 3, and 5 times. So each time you're going on putting this and get the answer. Or there is another student who will say, no, let me graph this on the desmos.com. So you can also graph this way, and then the graph will go this way, and try to reduce this your window to kind of, since the number is going to be quite a big, maybe 10 million, 15 million, put a million type of thing on the on your Desmos, and you'll see a line going, maybe this one is there, and somewhere there you'll see the answer will be 10. So when you go on multiplying, this will be 5 raised to 10, gives the answer already. Okay, so each strategy can be used, and I hope that helps. Okay, and I was just trying to show here, I was just making sure, look at this. So I made a slider here. I put a 5 raised to p and put a slider. You can see every time the exponent changes. So in the beginning it is 5 raised to 1, and then 5 raised to 2, then 5 raised to 3, and you go on, or you can just go on changing the exponent, or you just put y equals 5 raised to the power x. I can see the graph and change this to maybe 10 million. I'll just put this y-axis and put it like 10. See the graph here? Oh, sorry, mistake. Y. This one will change. 1. I'll put 10 million. That's 10, comma, and again, comma, and 10 three times. So, okay. You can see that and just put y. You want to know when it's going to be 1 million. So you put y equals 1. Oh, sorry, asking when it is going to be 10 million, right? Oh, 9. It says 9, 9, 7, 6, 5, 6, 2, 5. I think that's what it is. Whatever it is. Understand? So it doesn't take the comma, so I'll take the right. So now, so this one I put 10,000. I think I should put one more 0. That's like, and one more. So that takes care of. Uh, so where is this line y equals? Okay, here it is. I just try to type in y equals 5 raised to x and adjusted the y-axis to 15 million. That's like 1.5 raised to 10, 7. And then I put this 9. So that's what you want to know. How many 5s do I multiply? And the intersection point gives you the answer. And you can see the input is 10. So my x is, so n dot number of steps is 10 and you get 9.76. So basically if you multiply 10 raised to 6, you get 9765 and 625. So hope that helps. Problem 2. So take a minute to read the question and see if you can try it yourself. A bacteria population is modeled, so the number of bacteria allowed. Remember, this is the beginning when it was just counted. So 10,000 basically is when, that's the age. So if you think of the formula, the population, let's say pH. Now H is used, I'm just using the regular formula is A raised to B raised to X. And x is 0, 1, 2, and so on. So there's an increment of inputs as 1, 2, 3. 1. It's the same input every increment. So now this affects population. So instead of F, it was P, and hours is how many hours passed by since you counted the bacteria population. So it was 10,000 and you raised to H. H is, look, what is the question here? How long does it will take to, so when will this whole thing, so it means 10,000 times 2 raised to 8, so equals, when is it going to be 100,000? Now, so far, remember, we are going to dive into logarithm where it's become so easy to figure out what is the h in that. But right now, we are using without logarithm and say, hey, so and by what does this number 2 represents is the growth factor. That means it doubles, right? This is the factor, so it doubles. So it doubles. So you want to see, okay, 10,000. So you can just use your common sense and say, when do you think this will happen? So if you make a table, so in the beginning it is 10,000. So 1 hour, 2 hours, 3 hours, 4 hours, and say in the beginning it was, so H and the population of the bacteria. So you multiply 2, you get 20,000. Then you multiply 2 one more time, you get 40,000. Multiply one more times, you get 80,000. Okay, and multiply one more time, 88 is 160,000. So, and you can see this is high. They want to know when it's going to be in between. I'll just put, hey, what is this? Question mark. It's going to be 100,000. And you can see 100,000 is between 60 and 80,000, 60. That means between 3 hours and the 4 hours. So how long will it take for the population? So we can say to reach this, the answer is between 3 to 4 hours. Now 100 is very close to 80,000. We can say almost like 3 and something. So the question is, the answer you can say, hey, it, so the hours it will take for in order to have 100,000 will be between 3 to 4 hours. Hope that helps. Let's go to the next one. Problem number 3. Try yourself first. See if you can write the in your notebook maybe. I hope that helps. And look at this. So the input output is given. So 10. So remember 10 raised to 1 is 10. 10 raised to 2 is 100. 10 raised to 3 is you're multiplying 10 itself 3 times. And if it is 4, it becomes 10,000. So back of your mind, you should know this. So 10 raised to 5 is you multiply 5 zeros, 10 raised to 6, you multiply, that's like a million, right? See? And so on. So easy, very easy. So you're given 1000 means 10 raised to 3. Here the 1, 2, 3, 10 raised to, so not difficult. Then you go backwards, so 0 is 1 because 10 raised to 0 is always 1. And then you go backwards, there are because 10 raised to 2 is 100, so 10 raised to minus 2 will be 100. See, 100. So this will be 10 raised to minus 2. There are 4 here. So if there are 4 zeros, you write 10 raised to minus 4. Not easy. The difficult part is what about this? So this part uh, is a fraction. So if it is a fraction, so we write 10 raised to is 1/3 because every time say, hey, this is 10 raised to so this is 10 raised to 1. So how do you get this is because this part you're not supposed to write here. This is you write 3 and then it is 10 raised to 3. This should be 6 here. So I made a slight mistake here. You're supposed to write when will you get this? It is when it is going to be minus 3. When will you get 4 zeros? Minus 4. So you're supposed to write only how many times you multiply 10. So the question is how many times you multiply 10? Is that's the answer. So this 10 raised to 1/3 also is cube root of 10 by definition of cube roots. So remember, if I have b raised to 3 is some c, then b is cube root of 3, which is b. It means b raised to 1/3. So because b raised to 1/3 times b raised to 1/3 times b raised to 1/3, and if you add up all of them, plus 3 of them, you get b raised to 1. See? So that's all it is. So let's go to the next one. So the question is, so the graph is already given here. What is the approximate value of x? So the input, so we need to know what is the input for what x will the output, which is the y-axis is given, right? So the 10,000 go all the way, this is the output, you go all the way until it meets the graph, and you can see it meets here. So, but be careful, what is 10 raised to, so 10 raised to, so this part is, sorry, 3 raised to, this part 8, which is right here, this is 3, right? This is 8. So this part, if you go all the way up here, it's right here, right? And if it is 9, it goes up. So you want 10,000. So this black graph, I can extend it, I mean, somewhere here maybe. And the pink graph, it means somewhere here, see, like this. So between 8 and n, you can see 3 raised to 8 is maybe some. So 10,000 is like, this is like 3 raised to 8, which is between 60,000, 8,000. And this is 100,000 and 12,000 and 12, 14 and 16. So the point I'm making is this point, so this part is closer. So this graph, if you go down, it's closer to 8. So the question is, what is the approximate value of x? I would say it is 8 because it's more closer to 10,000. The output is more closer to 8. See, because if it is 9, it's quite up here. So this is too much higher, which is almost like 16,000 maybe, but it's closer to 8. So I hope that helps. So the answer is 8. So x equals to 8. So let's go to the next. So question number 5. is one account doubles every 2 years, the second account triples every 3 years. Assume that the account starts the same money. So basically, what it says is like the first one is, let's say there was money here, and here also there's money here. In the beginning, they had the same money, maybe let's just imagine $50, okay? And this doubles 2 years, and this doubles 3 years. That means we want to know which account is growing fast. So how do we know? So think about it, pause the video for a while and think, what do you think is the answer? How do we know this? So the best way to do is, hey, what about each year, what is the growth factor? So the one that they gave us here is it doubles. So what is the meaning of doubles? Means from here to here, you're multiplying by 2. So it's like 2 times 50 is 100. So what about this part? So each year, what is that? That means each year will be, so there are 2 years, right? 1, 2. So it's like there are two parts. So 1, 2. So that means what is that? Let me put C here. You don't know, put it like C. What is that? C multiply itself twice gives you 2, because this is 2, right? Doubles. And you can say C square is 2, and C is 2 square root of 2. Or C is 2 raised to 1. 2 raised to 1. And then what about here? This triple. So this is 3 here. That means we want to know here how many C's? 1, 2, and 3. So that means C, C, C. So C cube E should be 3. So that means C is cube root of 3, which is 3 raised to 1. So each year, the first one, the growth factor is 2 raised to half. The second one, the growth factor, so this one, the growth factor 3 raised to half. And clearly see this, both have the same exponents, but the base here is 2. So the greater the base is, so 3 is greater than 2. That means whatever the triples, it grows rapidly. So the question is, which account grows rapidly? So this account grows rapidly. Each year it is growth factor is 3 raised to half. This is 2 raised to half, and clearly this is higher than 2 raised to half. Let's go to the next. So in this case, we are you see the graph. This is the input and output. So the question is, they didn't give us nothing about what is this function a. Of course, we can easily figure out in this figure. A is where it starts, and that's like, this is 100, and the in between is 50. So already this is 50, right? So we want to know what is B. So let's check here. Look at this one. From 50 it goes to 100, right? So it means if I make a table, 0 is 50 and 1 is 100, and if say 2 is 200, 3 is 400, so you can clearly see that, and 4 is 800. So the question is, how would you describe the output for this graph for the input from 0 to 1? So our goal is only from 0 to 1. What do you see? So from 0 to 1, you can see this graph. So that means 0 to 1 from here to here. And you can see 100 divided by 50 is 2. It doubles, right? So that's what the question is. So you just say there is a growth factor of 2. So for the input 0 to 1, the growth factor doubles. Then what about from 3? So the next one is 3 to 4. So what about here? So for the output 3/4, let me check. You can see here. So this is 400 and this is 800. The same thing. So 800 divided by 400, which is 2. So that's the growth factor. So both have the same growth factor 2, and this also is 2. So hope that helps. That 50. So what does that mean? So it doubles. So what is doubles basically means growth factor is 2. It means it is 1 plus 1. Then it's like 100% plus 100%. So there is an increase. The percent increase is 100%. That's what I'm trying to say. Okay. So let's go to the next. Okay, look, watch this. So the last question, question number 6 or 7, I think you can check that out. Complete the table, and you see the carbon 14 is a special one which usually whatever milligrams or grams of fossil. Let's this is a uh, in the fossil if there was some kind of a, let's say there was a milligrams or grams. In this example, it is like showing is picograms, right? So in the beginning, there were three picograms. So what's happening is, what does this mean? This is 5,735 because carbon 14 every 5,730 is always, it's called half-life. That means half-life basically means whatever the carbon is in the beginning, amount of carbon may be picograms or 5 grams, whatever that is, it becomes half. So this is 1.5, half of 3. Then again it becomes 0.75. See? So another 5,730, then another 5,730 becomes 0. Half of that. So it's 375. See? And then again you multiply 0. You make a half of this and you get 0.18 and 115.75. See? So, and the next one, so the question is, when will it be like until there is so much picograms? So that means there's another time you do like 5 of those half lives, and you multiply by half, and you get 0.09. I think these 325. See, and this number is smaller than 0.1. So that's how it is. So after five half life, that's what that means. So after half life, the amount of picograms remaining in the fossil is smaller than 0.1 picograms. Oh, the answers are already there. I didn't realize. Oh, yes. I hope this helps. Thank you. And as I said, I'm just making a lot of videos like this. What I'm trying to do in this is unit 4, lesson number 8, and this is about the lesson is, let me show you if you see practice problem. This is I am illustrative mathematics, and this is the lesson. This is what you do in the classroom. But what I'm trying to do is, because the teachers don't have enough time to complete, I'm trying to have a little assistance for students who are maybe struggling or maybe unable to do. And that's what I'm trying to see. These are all the problems from practice problem, which every teacher cannot finish in the class. So I thought of, being a little help, maybe resource. So hope that helps. Continue watching the videos, and I'll be posting the next one on logarithm practice problem lesson number 9. Thank you.